Hello all. So today in this video, we'll be looking at modulation techniques used in TV broadcasting. We'll learn about what are the modulation techniques that are used and also look into what modulation is. So let's go into the session. So these are the contents that we'll be looking at today. That is the introduction. We'll be knowing about what modulation is and we'll know what all are the modulation techniques that are used. Then we'll be studying about them in brief to analyze them, what they do, how they work, and what are the advantages and disadvantages of each of these modulation techniques. Then we'll be looking at them as a short form in a tabular representation, and then we'll conclude the session with it. So let's go further. So what is modulation? We know that modulation is a process or a method in which you vary the factors of a carrier signal, that is either their amplitude, frequency, or their phase, to help us to transfer message or to send a message from one place to another, in particular to long range message transfers. So this is used mainly in transfer of audio, video, and other data. We are focusing mostly on the digital part of it. That is where we send the data coded in forms of zeros and ones. That is the audio, video, and data will be coded in zeros and ones, and that will be transferred from the transmitter to the receiver end, where it will be decoded, and you'll have the further process of the video taken out, extracted, and it will be displayed. So let's see further in it. Modulation techniques that are used in digital TV broadcasting. As I said that we'll be using modulation techniques to transfer all the audio and video. Uh, we all use TVs to watch shows and many other programs in it. So how do all these informations that are being transferred from the stations or the TV places to our houses? We use various techniques such as the ones referred over here, 8VSB, QPSK, QAM, and COFDM. So these are a few reliable transmission methods which give us a high quality video and audio displays. It uses a specific modulation technique that efficiently encode the digital data out onto a carrier signal. So let's see what all these techniques are in a much more briefer way. So 8VSP, or the 8-level vestigial sideband modulation. What is this 8-level vestigial sideband modulation? Uh, it is a type of modulation where you actually split up the single band into multiple sidebands. That you'll have one band and you'll have multiple sidebands for each of them, which will carry the data that is being encoded to the receiver or to our TVs in this case. So the primary use of this is placed in US and some parts of North America, and they use the Advanced Television System Committee standards for the data transfer. So how it works? As I said that 8VSP uses 8 discrete amplitude levels to represent digital data. That is, these sidebands are divided into 8 discrete amplitude levels. Unlike the regular amplitude modulation, which has symmetrical sidebands, the 8VSB has one full sideband and a vestigial sideband. That is, you have one complete sideband that is going to be like a reference sideband that is in the middle, and you'll have the remaining sidebands spread across this one sideband with decreasing amplitude values, and they all keep going lower and lower up to a certain amplitude value, and then we don't have any sidebands at all. The advantage of using this is that you can transfer the data to a longer distance with a narrower bandwidth. You don't need to use a wide range of bandwidth for the data transfer. As that is, they give us a high spectral efficiency, and you don't have a interference in path. When the data is transferred, there's no path interference happening into our information, which is particularly useful in urban areas where signals can reflect off buildings. And the disadvantage of this is it is high likely to be affected by signal degradation compared to other modulation techniques like OFDMs. So now looking at QPSK, quadrature phase shift keying. This is frequently used in satellite broadcastings, and a basic example that we can take is our DTH, where you have the dishes to transfer the TV channels broadcasted data to us. So they have given the example of DVBS, that is Digital Video Broadcasting Satellite. And the way it works is it modulates the data by shifting the phase of the carrier signal in four distinct ways, with each phase shift representing 2 bits of data. So the QPSK works with double bit data, that is like something like 0001 10 and 11. And whenever you have the change of these bits in the data, the phase of the carrier will be changing. That is, if the bit data is changing from 0 to 1 or 1 to 0, there will be a phase shift. According to that, the data will be encoded and it will be transferred to us. And this technique allows efficient data transmission with a relative low error rate. And the advantage is the same thing, we have a high spectral efficiency, meaning it can transmit more data in a given bandwidth. And it is a very good, how can I say that, a very good robust technology against noise, making it suitable for long range transmissions as required in satellite broadcasting. And the disadvantage is that we need to have a high signal to noise ratio so that we don't have any distortions or any disturbances in our signals compared to other some other methods. So now looking at QAM, that is quadrature amplitude modulation. They are commonly used in cable TV broadcastings, and these cable TV broadcasting that I'm speaking about is the ones that we use in our homes, the set-top boxes that are connected, where we have the cables run to throughout the lanes to give us the broadcastings. But the disadvantage in this thing is that we'll be seeing about this in the further about what I'm trying to say right now. The only thing we can do over here is that to transfer the video and audio data. There is another method that is COFDM where we can also transfer the Ethernet things like to have internet facility and etc. Also using the same cable TV broadcasting method itself. So first, let's look at this and we'll go to that further. So commonly used in cable TV broadcasting as seen in the DVB-C, that is digital video broadcasting cable standard. And how it works, it combines both amplitude and phase modulation. We've seen amplitude modulation separately and phase modulation separately in QPSK and uh, the previous one. So now we'll be looking at something where we use both amplitude and phase modulation together. Each symbol can be represented by multiple bits by changing the signal's amplitude and phase. Variants like 64 QAM and 256 QAM allow high data capacity by encoding more bits per symbol. And the benefits is that we have a high data rate suitable for high definitions. That is, you can have a high quality data being transferred to us, which is something like the HD channels that we have and the normal channel. HD channels are the basic example for having a high data rate. So contents and large data streams, highly efficient in terms of bandwidth usage, allowing for multiple channels to be transmitted simultaneously. And the drawback is that it will be more susceptible or more highly affected by noise and interferences, requiring a high SNR ratio for reliable transmission, just like the QPSK. Now looking at the COFDM, as I said that this is a terrestrial broadcasting system, and over here we can also be using it to transfer Ethernet data like having an internet connection or Wi-Fi connections also along with the normal cable TV connections along with it. And they are mostly used in Europe. And the previous one that we saw, that is the QAM, it is mostly used in India and some parts of Australia also. Now looking at how it works. So COFDM splits the data across multiple subcarriers, each with a different frequency. So it will split the data with respect to different frequencies, and these subcarriers are spaced orthogonally to prevent interference between them. The coded part means that the error correction codes are added to protect data from interference, which is that you will have some kind of as you know that there are some guard bands between each bandwidth when you're transferring data. These coded parts actually work as those guard bands to protect the data from interfering with each other when we are transferring them with different frequencies. So the benefit of this is that extremely resistant to multipath interference. We won't have any interference of path. That is, we have a high resistance to those path interference and fading of the signal. We won't have the signal being distorted in the way of transmission, making it ideal for dense urban environments, scalable bandwidth, supporting HD and even 4K broadcasts. And the disadvantage is that it is too complex to be implemented due to the need for many subcarriers and advanced signal processings. So this is a tablet representation of the data that we study right now that will just speak about what are the techniques and what type of the standards are used over here, what type of network system we'll be using, and the advantages and disadvantages. As we saw that 8VSP, it uses the ATSC standards, and it is terrestrial based in data transfer or the audio and video transfer for our televisions. It is highly efficient, multiple resistant, and the disadvantages that limited robustness in long distance transmissions. Looking at QPSK, we have the DVB standards, that is digital video broadcasting satellite standards, where we use satellites for the broadcasting of our information to our TVs. The advantage is that it has a high spectral efficiency and it is also robust. But the disadvantage is we need to have a high SNR ratio to prevent any disturbances. And that is quadrature amplitude modulation. We saw that it uses both amplitude and phase modulation. That is both combination of 8VSP and QPSKs. So it uses the DVB-C standards, that is digital video broadcasting cable standards, where we have the cable wires running through all the lanes to our TVs from the stations to transfer the data. It has a high data rate and it is sensitive to noise. So now looking at COFDM, DVB-T, that is digital video broadcasting terrestrial. So it uses again the same thing as terrestrial as the first one. It has a very good advantage of multipath resistance. It is not having any interference of channels in between them, and it is scalable. But the disadvantage is that it is too complex to be implemented in real life. I mean, it is implemented in real life, but not in multiple places. So the conclusion is that modulation techniques in digital broadcasting are essential for efficient data transfer. We need to have this modulation technique so that we can transfer data from a very longer range to our houses and to many other places. So using various techniques like 8VSB, QPSK, QAMs, and COFDM, each offer has a unique advantage and they have their own disadvantages, but they help us to transfer the data much more efficiently and to be more robust against interferences. So by choosing the right modulation techniques, broadcasters can ensure high quality, reliable digital TV services across different platforms. So this is all about the modulation techniques that we'll be seeing in the TV broadcastings. So thank you.